Hi, this is Ashish from developerhut.net and welcome to Java Design Pattern series. So, in today's session, we'll be going to see the most interesting and my favorite design pattern, which is strategy design pattern. So, this is the agenda for this session. So, before we move ahead, what exactly the strategy design pattern? First, we will understand the problem statement, and later we will see what exactly the strategy design pattern is. Then we will going to see what are the rules or steps how to create the strategy design pattern, and then we will implement the strategy design pattern using our toy factory application. And lastly, we will see the summary as well as the conclusion. Now let's assume that you are the owner of the toy factory company who is specialized in creating the different type of toys. Now this toy company has a very famous category, which is the animal category, where your company is creating a different type of animal toys like dog, duck, snake and hundreds of other type of toys. Now all these toys have one application installed in this, and this application has a one feature which is displaying the name of that particular animal on the console. Right now your sales team wanted to increase the sale of all your toys, and they ask business team to come up with some additional features. Now business team analyze and they come up with two new additional features. So now business team ask you to add these two features. The first is of course the walk feature. So all my toys should walk as well as all my toys should fly. Okay, apart from this, business team also wanted to change this both features during the runtime. So this is our actual requirement. So now let's first understand the application structure, right? So here we have one animal class which is very abstract in nature, and all the other concrete classes extending the animal class, right? Now whatever the features walk and fly method which we are going to add, all these two features we can add it using the two approaches. The first approach is of course by using the inheritance. So first we will try to solve this problem using inheritance. Okay, the first way what we can do in this case is we can add the abstract implementation of methods in the base class. So what happened in this case, so if we add the abstract version of this walk and fly method in base class, then we will get the compile time error, right? Because all other concrete classes has to implement these two methods, right? And there are hundreds of classes, concrete classes, which are extending this animal class, right? So this solution is not feasible in this case, right? So we cannot add this abstract method in a base class. Now next way to add this is what we can do, we can add the dummy implementation or a concrete implementation in the base class, right? So what happened in this case, so if we add the some implementation in base class, we won't get the compile time error. However, what we want here is we want these two features to be implementation specific, right? And another problem with this approach is if you add the some implementation in the base class, it will be available for all the classes, right? And also few features are unwanted for some other abstract class, right? For example, fly feature is not required for dog class or a snake class, but we are adding it in a base class, so it will be available for those classes, right? So this approach is also not feasible. Last approach what we can do here is we can add the empty implementation in the animal class, and we can override only those method in other concrete classes. For example, fly method we can only override in a duck class, right? However, this is still not suffice our problem, right? So our third requirement was to change this behavior dynamically during the runtime, right? So if you add the implementation in a duck class for the fly method, this particular feature is marked permanently for this duck class, and we cannot change this behavior during the runtime, right? We will be going to see this. So in this case, inheritance is not the solution for this problem statement, right? So till now we try to solve this problem using inheritance. Now let's try to solve this problem using the composition, right? So what exactly the composition is? In very simple terms, composition is creating the reference of any particular object inside the particular class, right? So for example, we will be creating the reference of some object inside the animal, right? Now what exactly this some object is? So if you see carefully, features that we are trying to add, those two features are nothing but the behaviors, right? So now to convert these two behaviors into the references, what we will do, we will separate out these two behavior in classes, right? Or simply we will use the interface for clear separation and the clarity, right? So what I will do, I will create two separate interface. One is a walkable and another is a flyable, and we will add the respective methods inside these two interfaces, right? So now here we have the two interfaces. However, how we can use these interfaces, right? So what we will do, we will create two methods inside the animal. For example, let's say I will create a method let's walk, and I will simply use the walkable interface to call the walk method, and I will create another method let's fly, and I will use the fly interface reference to call the fly method, right? So here if you see, there are no changes at the concrete classes at all, or even the compile time error, because you have added the reference in the animal class, which is the base class, right? Still there is, we are still not able to address our last requirement, which is changing this behavior at the runtime, right? So let's see how we can update this behavior during the runtime. So let's assume that there are multiple concrete classes who are implementing this walkable and flyable, right? So for example, walkable has one concrete class which is walk with legs, and another is walk with wheels, right? So which provide the implementation of a walk method according to these two classes, right? And flyable interface has another method which is fly with wings and fly with rocket, right? So now what I want is, during runtime I want to update this implementation dynamically, right? So first of all, if I set the reference of fly with wings, then after some time I want to set the fly with rocket, right? So how you can change this behavior during the runtime, right? So it's very easy. What you can do, you can create the setter method inside the animal class, right? So which will set the appropriate class during the runtime and then call the walk method or fly method, right? So what happened in this case, you can achieve the feature of changing the behavior dynamically during the runtime, right? So now here you can see we have added all the new features, right? As well as there is no or negligible changes in the concrete classes like dog, duck, snakes. There are no changes at all. Whatever changes we had added in the base class, right? And third is we also achieve the our last feature, which is changing this behavior during the runtime, right? And what we have used the composition for this. So this approach what we have used is basically called as a strategy design pattern. Now let's understand what exactly the strategy design pattern. So what is strategy design pattern? So strategy is an behavioral design pattern, right? And it converts all your behavior into the objects, right? Like we have a walk behavior and we have a fly behavior, which we have converted into the interface, which later converted into the objects, right? And strategy help you to create multiple implementation of the same behavior, right? So we have created the walk with legs as well as walk with wheels. So there are two separate implementation of the walk behavior, right? And strategy design pattern helps you to change this behavior during the runtime, right? So you can assign walk with wheels first, and then you can assign the walk with legs later, right? This happen during the runtime without affecting any of your code or any of your implementation. Now let's look at the steps or rules how to create the strategy design pattern. So the first thing that you need to do is you need to identify the behavior, which is the most difficult thing in the strategy design pattern. So first, here what we have identified is walk and fly are those are behaviors which we have to separate it out. Okay, next is we need to create the abstraction of a behavior using the interface. We will separate out all this behavior in separate classes or separate interfaces. Then we will create the reference of all these interfaces using composition, and we added in a client which is animal class in our example, right? And we have added the method in a client to call the methods of walk and fly using this reference, right? So we have created the let's walk and let's fly method where we have called this walk and fly methods. And last is, of course, we need to create the setter methods in a client class to set the reference of the interface. So these are the steps and rules which we need to take into consideration while creating the strategy design pattern. So now let's move ahead. So to save a little bit of time, I have created the base structure of this program. So we have an animal class, right, which is of course abstract in nature. It has one member variable which is name, name of that particular animal, and constructor will take the name of the animal and it will simply set that name to this particular instance variable. This class is also have a display method which is common for all the animals, right? So it will simply print the name of that particular animal, right, which what we discussed in our earlier slides, right? Then we have created the other classes which is who is extending this animal class, right? So we have a dog who extends animal, and in constructor we will simply pass the name of that particular animal which is dog, right? The same for a duck, right? So we have created a duck and we are passing the duck as name of the duck in the constructor, right, to super constructor, and same for the snake as well. Now we have created the client, right? Here we will create the reference of animal, use the reference of the animal, right? And we will create the object of the our actual concrete class, right? So and from animal we will simply call the display method. So same way we will use the same reference, right, and we'll call the our concrete class object, right, and we'll simply call the display method. Now if you simply run this Java application, you can see you are getting the name of that particular animal, right? So this is our base structure. So now let's quickly try to solve this problem using inheritance, which I explained in my earlier slides. So first approach what we did is we tried to add the abstract method, right? So if you added the abstract method walk and fly, the walk and fly features, right? So what will be the issue will be you will get the compile time error, right, in all your extending classes. So adding the abstract methods is not feasible at all, right? Then next we try to add the dummy implementation, right? So what happened in dummy implementation, you won't get the compile time error, right? And you will what you will do here, so we will simply overwrite the methods, right? So let's say I will just add the block and say overwrite, right? So I will simply go here, and here we don't have any compile time error because we have added the dummy implementation in a base class, right? And we will simply go ahead and I will simply call this, right? So I will say walk, right? And if I run this, yes, of course it will work, right? However, now you have added the fixed implementation, right? So let's say in future if I want to add the walking with wheels, right, so I can't add it because this implementation is fixed for this dog class, right? So this is the problem with the our inheritance approach. Now let's proceed ahead with the composition approach. So now let's go ahead and solve this problem using composition approach. So what we'll do, we will simply create new interfaces, right? So I will say walkable, right? And I will simply add one more method which is walk method, right? So we'll say void, okay, and we'll create another interface which is for our fly behavior, right? So I will say new and I will say interface flyable, right? And here I will say void fly, right? Let's create the reference in animal class, so I will simply go here. I will say walkable, right? I will say walk behavior, right? And I will say protected, flyable, and I will say fly behavior, right? Yeah, so that's it, right? So we have walkable and flyable behavior ready, right? Now let's create the method. So I will say public, and I will say void. I will say let's walk, right? This method is definitely required because we are going to call this the walk and fly method from here using this two reference, right? So I will say uh, walk here, not wait, I will say walk over here, right? And I will simply go ahead and copy this and create the method for fly, right? So I will say let's fly, right? And here I will say fly behavior dot fly, right? So we have methods ready. So now till now you can see there are no compile time errors in all our concrete classes as of now, right? And if you simply even call this animal dot, let's say let's walk, right? So this will still, there is still no compile time error, right? However, if um, run this program, you will of course get the runtime exception, which is null pointer, because we haven't set any concrete classes yet, right? So now let's create the concrete classes. So I'll simply go to the walkable, right? And let's create one concrete class for walk. Okay, so I will go here, I will say walk with legs. Okay, and the interface which is implementing is of course the walkable, right? And here I will simply say sysum. I will add some implementation. I will say walking with legs, right? And let's create the same for flyable. So I will go here, I will say new, I will say class, and I will say fly with wings, which implements the flyable, right? And here I will say sysout, and I will say flying with wings, right? So we have our concrete classes ready, right? Now how we can set it? So there are multiple ways. Either you can set some default behavior in all the classes, right? So what I'll do, I will say this dot um, for, let's say, walk behavior, right? So I will say walk behavior and a new walk with legs, right? So I have assigned this default behavior to dog class, okay? And I will do the same for duck. So I will say duck this dot fly behavior is equal to fly with wings, right? So I will say fly with wings. These are the two default behavior I have assigned it to them. Now if you simply run this, so we will be able to get the output, right? Now next is what we want is we want this behavior to be changed during the runtime, right? So there are two new behaviors maybe we have added. So I will just simply copy the walk with legs, right? And I will say walk with wheels, right? And I will simply change the implementation, okay? And I added a new fly behavior, which is, let's say, fly with rocket, right? And I will change the behavior as well, right? I'll say rocket. Now how we can change this behavior? So we need to add the appropriate setter methods, right? So I will go to the animal class and I will go here and I will say generate getter setter. I will select the setter. We don't need name as of now, right? So I will say generate, right? So we have this. Now you can change the behavior dynamically now. So if you go ahead here, so first of course dog was walking with legs, right? So I will say now set walk behavior and I will say new uh, walk with fields, right? And we will call the let's walk again, right? So we can test this behavior. Same we can do for duck as well. So I will say animal dot set fly behavior, right? And I will say new fly with rocket this time, okay? And I will simply call the fly method, right? So now if you run this, you can see. So all my toys are changing their behavior during the runtime, right? So without any code changes. So this is how strategy design pattern works. So this is the best advantage of a strategy design pattern, and it is very useful in most of the cases. However, you need to first identify the behavior, as I said earlier, right? And this design pattern is very useful in a maintenance phase, right? So whenever, let's say, if you have already application, you are adding new changes, in that case it's very easy to add the changes without affecting the existing code changes. So now let's look at the summary. So strategy encapsulates the behavior in a classes, and it allows a client to choose any behavior during the runtime. This is the most important advantage we can say in a strategy design pattern. Strategy also allows you to modify or add the behavior at the runtime without any modification in existing code. This is also the major advantage of a strategy design pattern. So here we saw how we have added the additional walk as well as additional fly behaviors in our code, right? And we simply set the object of those and in the client, and we run the code. However, there are no changes in the concrete classes as well as there are no changes in the base classes except the client class, right? So this is the strategy design pattern. Now the real world use cases. So collection.sort method internally uses the strategy design pattern, right? Even if you are familiar with servlet and JSPs, right? So HTTP servlet class internally use strategy pattern to call the service as well as do get do post methods, right? And filter class, which belongs to servlet javax.servlet package, again use the strategy to call the do filter method. So I hope you understand the strategy design pattern. So as I said earlier, design pattern is such a subject which is very easy to understand. However, it's very difficult to implement. So as I said earlier, I suggest all of you to go ahead and create this sample program on your machine, and then you can use this strategy design pattern in your day-to-day activities, right? I also uploaded this complete program on my GitHub repository as well, right? And you can find the link of the GitHub repository on the description section below. So if you have any queries, question or suggestion on the strategy design pattern, please add it in the comment section below. Your ideas will be really appreciated by others as well. Thank you very much for watching, and I will see you on the next one. Thank you.